Hello. Now I want to talk about the task number 5. Initially, we chose to work on the fashion amnesty dataset. Uh, so first, at first stage, we wanted to apply logistic and linear regression models from which were developed for the task 4. Let's have a quick look at it. So we downloaded the fashion dataset, amnesty dataset, and we specified the directory and we separated the samples from its labels. So the shape is, let's see, not extreme, let's make it shape. After some time it will show. Okay, so the shape is 6000 by 784, 60,000 by 784. Next, this is the same logistic regression function from the exercise 4. We just changed the number of features here, and we didn't change the number of iteration and the step size. They remained the same. And we also used the linear regression for binary classification function from the task 4, OVA formation and OVA error. They are all from task 4. When we use this both linear and logistic regressions, let me run it here, for example. Yes, it runs. The result is equal to this. So, for example, error for the linear regression, test error for the linear regression is 17% or 18%. So the accuracy is 88%. Is around 88%. For the logistic regression, it is around 70%. So it's not that good. And for that, we further wanted to check what if we change the regularization parameter lambda. So for that, we changed, varied the value of lambda from 0 to 1000. Using the exhaustive search, we obtained these following values. The lowest test error for the linear regression doesn't change. So for the lambda of 0, it has the lowest error, but for the logistic regression, it's at lambda value of 222 and 0.2. It reaches this value 0.28 error, 28 or 29%. Before it was 30%. So there is some drop actually, but it's not enough. So we decided to challenge ourselves and to start using apply convolutional neural network, very simple one, because it's like usual, because it's in nature image classification task. So for that, we needed to reshape our data into the matrix form, from the rows to the matrices form, because 784, it is 28 by 28 image size of the one channel only, gray. And the labels were encoded also to binary class matrix, because we cannot work with numbers from 0 to 9 directly. So we used here we normalized our input samples or input features by using the normalized function provided by Keras, and the model was chosen as sequential. The first layer is a convolutional 2D convolutional layer with a filter of 32 and the kernel of size 3 by 3. And activation function was used rectified linear unit, and the kernel initializer, it's a uniform initializer. It uniformly chooses, like randomly chooses from the sample. Input shape corresponds to the input shape of our images. Max pooling, the next layer, and after max pooling, after these two layers, we eventually flatten back our data to a row, because we need to fit it to the next layer, which is fully connected dense layer with 100 neurons. And last layer is also a dense layer with 10 neurons only, because there are 10 classes. And we also used softmax activation function because we wanted to have probabilities for these 10 classes as outputs. So when we compiled, we chose the optimizer, like the most used one, as atom classifier, the Atom optimizer, and the loss function was categorical cross entropy. And when we trained with 10 epochs and batch size of 32, the training error was quite high, 96 or even higher, a bit higher. But when we checked on the test data set, it reached the accuracy of 91. So we decided to upload this solution, the convolutional neural network, from here to the Kaggle. Yes, as you can see, I have already submitted in by my account. It is right here. You can find it from within uh, all the codes, all the solutions. So I think yeah, it's right here. It is exactly the same code, but the only thing that user needs to do, yeah, because these errors why they're present, because of this part, they need to specify the directory. Yeah, basically this is it. In general, it works quite well, as it was shown here. I can rerun it, but it will. Sorry. Yeah, it will take some time. As you can see, the accuracy, training accuracy already increases. So we can stop here. We can stop here, and thank you for your attention.